Hello everyone and welcome to this presentation on the Fibonacci sequence. My name is Ramanullah Rahmani and today we will be exploring one of the most fascinating sequences in mathematics. Contents. Here is what we will be covering in this presentation. What is Fibonacci sequence? The mathematical formula. Finding Fibonacci numbers using recursion. Finding Fibonacci numbers using dynamic programming. What is the Fibonacci sequence? The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding numbers. It begins with 0 and 1 and continues. For example, the sequence starts as 0, 1, 1, 2, 3, 4, 8, 13, and 21, and so on. Each subsequent number is simply the sum of the two numbers before it. The mathematical formula. The end of the Fibonacci sequence is represented as Fn, and it follows this recursive formula. Fn equals Fn minus 1 plus Fn minus 2. The sequence starts with the initial value f0 equals 0 and f1 equals 1. For example, to calculate the second and third terms, f2 equals f0 plus f1, which is 1 plus 0 equaling 1. Similarly, f3 equals f1 plus f2, which is also 1. Finding Fibonacci numbers using recursion. The Fibonacci sequence can also be defined recursively with the same formula. Fn equals Fn minus 1 plus Fn minus 2. However, the time complexity for this approach is exponential, as each function call results in two more function calls. The auxiliary space complexity is O(n) due to the maximum depth of the recursion tree. Finding Fibonacci numbers using dynamic programming. Dynamic programming optimizes the Fibonacci calculation by storing previously computed values. This approach significantly reduces the time complexity to O(n), and the auxiliary space is also O of n. Thank you all for your attention and participation. I hope you found this presentation on the Fibonacci sequence both informative and engaging. Hello everyone and welcome to this presentation on counting the total possible combinations of n-digit numbers using a mobile keypad. My name is Ramanullah Rahmani and I will be guiding you through this interesting topic. Keypad representation. The mobile keypad is structured as a two-dimensional grid where each digit is placed in a specific position. It is important to note that the keys star and hash are not used in this scenario. For each digit, we map out the digits that can be reached by moving up, down, left, and right, or by staying in the same position on the keypad. Directions for a given number. Here is how the directions work for each number. For 0, you can stay at 0 or move to 8. For 1, the reachable digits are 1, 2, and 4. For 2, the reachable digits are 1, 2, 3, and 5. For 3, you can move to 2 or 6, and also you can stay at 3. For 4, the reachable digits are 1, 4, 5, 7, and so on through the end. Dynamic programming. We can approach this problem using dynamic programming because it has an optimal substructure. Essentially, the problem can be broken down into smaller subproblems which can further be divided into similar subproblems until the solution becomes obvious. Time and space complexity. The time complexity for this problem is of n square because for each digit and each length we calculate the number of possible combinations. Each calculation involves checking the adjacent digits. The space complexity is also of n due to the storage required for memorization. Here I am going to find the total combinations for n1 and n2. We have 10 digit numbers in the keypad from 0 to 9. If n equals 1, then we have one option for the 0, only take 0 or stay on 0. 1, for 1 also 1, for 2 also 1. For all of them we have one option. So here we have total 10 possible numbers. For 4 we have 4 options: move left, right, sorry. For 4 we have 4 options: move up, right, down, and or stay on 4. For 5 we have 5 options: stay on 5, or move to up, right, left, or down. For 6 we have 4 options: move up, move left, move down, or stay on 6. For 7 we have 4 options, sorry. For 6 we have 4 options: move up, move left, move down, or stay on 6. We have 4 options. For 7 we have 4 options: move up, move right, move down, or stay on 7. We have 4 options. For 8 we have 5 options: stay on 8, move down to 0, or move to left, move right, or move up. For 9 we have 3 options: stay on 9, move up, move left. three options. So we have total number of 36 digit combinations. For 0 we have we for 0 we have 0 0 0 1. For 1 we have 1 1 1 2 1 3. For 2 we have 2 3 2 5 2 1 or 2 2, and so on. Here is the code for total number of combinations of n digits in mobile keypad. Is valid. It checks if the given position I, J on the keypad is valid or not. It returns false if the position corresponds to the star or hash keys, which are located at 3 1 and 3 2, 0 1 2 3, 3 0 and 3 2. For any other position on the keypad within the bounds of the 4 on 3 grid, it returns true. Fill dictionary creates a dictionary that maps each digit on the keypad to the digits that can be reached from it by moving down, left, right, or up. The function iterates through each digit on the keypad. For each digit, it checks the 4 possible directions: up, down, left, or right, and adds the adjacent valid digits to a dictionary. This dictionary mapping helps in identifying which digits can be reached from a given digit when forming n-digit numbers. Get count recursively counts all possible n-digit numbers starting from a given digit I. If the length of the number is 1, it returns 1 because a single digit is a valid combination. It checks if the result for digit I and length n is already computed and stored in the lookup. If not, it computes it by considering all possible next digits and summing up the counts recursively. The function uses memoization by storing results in lookup to avoid recalculation the same values. Then we have the function find counts. Computes the total number of possible n-digit numbers that can be formed using the keypad. It first creates the dictionary. Mapping using fill dictionary, which maps each digit to its adjacent digits. It initializes a lookup table to store the results of subproblems for each digit and a length combination. It then iterates over each digit on the keypad and uses get count to sum up the counts of all possible n-digit numbers starting from each digit. Finally, it returns the total count. Main block the entry point of the program and sets the initial values.